We're going to go solving quadratics by graphing. So when we talk about solving quadratic, it's because you're trying to find some values of x. Okay, so right now we have an equation, and it has a side that's here's our equation, and it's set equal to negative x squared. In order to really solve for a quadratic, we need to set it equal to 0, because if it's set equal to anything else, it gets relatively difficult to work with. So because there's only one term on this side, we're going to move this to the left side of the equation. And because it's negative, it will then become positive x squared. This is plus x plus 3. And on the right side, because we've essentially taken away all the terms, we're left with 0. Okay, so we've now set the whole thing equal to 0. The next step is to find x-intercepts. Okay, in other words, we're going to go, this is in standard form, okay, and we're going to put it to factored form. And you can either use a quadratic formula, factored form. You can use a quadratic formula, or you can factor, and essentially the same as the name. If you remember, standard form is a x squared plus bx plus c. So it looks like this, if you recall. And then to go from there to the factored form, we have x minus r, x minus s, and then there's an a value also in front. So we're going to go from one to the other here. That's the whole point of this, okay? So you do decomposition, I believe, right? Mm-hmm. Well, in this one, the a value is 1, so there's actually a little bit of a trick. And actually, no, we'll just use the normal decomposition. But the trick would be, if there's only an a value of 1, you really only need 2 numbers that add up to this 1 and multiply to this 3 here, okay? That's all you need in order to figure this out. And this is 1 and 3. Oh, okay. So if we were to go through our factoring, sorry, I was thrown for a loop because I expected this to be a little simpler. Let's actually go through that using that shortcut. Let's say I need 2 numbers that multiply to 3 and add to 1. Do we have such a thing? There's only 2 numbers that multiply to 3, and they're 1 and 3. And 1 and 3, whether they're negative or positive, don't add to 1. So that isn't going to work. Something called discriminant. And it turns out this one has no x-intercept. So actually the way to graph this would be to take it to vertex form, okay? But that's not really what we want to focus on right now. You would have to do completing the square in order to do that. So I'm going to change this question around just a little so that it is something that we can do. I probably should have preempted this a little, but let's change this because we just went up and looked up another question very quickly. I'm going to change a couple values here. We're going to say that this is negative 4x and plus 4. So we're going to change the original question here, okay? Which is fine. Negative 4x plus 4. Same idea we had, still bring this over. We still get these values. We still set it equal to 0. So let's look for 2 numbers that multiply to our positive 4 here, okay? And they're going to add to negative 4. Okay. Well, we have the options of 1 and 4. But even if those are both negative, that doesn't really work out for us. We have another one, though. What about 2? 2 times 2 is 4. And 2 plus 2 is positive 4. But if I want to make it negative 4, if I make both of these negative, negative 2 plus negative 2 is negative 4. And negative 2 times negative 2 is still positive 4. So those work. So this is one of those shortcuts for factoring. Instead of having to do the whole decomposition, because the a value is only 1 here, I just have to put an x in each bracket. Have you guys learned this trick before?
No.
No? You could have done this the same way through decomposition, where you would have now split this into negative 2x, and did the common factoring of the both, and you would have ended up right here. This is just a little shortcut, okay? And since this isn't really factoring, we're just going to go with what we have here. But don't forget that this is still set equal to 0, okay? So we did our factoring. We're now in our factored form. It's set equal to 0. Now, what this is y is equal to 0. So we're finding x-intercepts. So whenever y is equal to 0, that's when we're on the x-axis. So we're trying to find what the x-intercepts are. We don't know what they are yet. This bracket, think of it like some term. You know, you could call this x and this y, and x times y equals 0. Well, in order to multiply to 0, one of these terms has to be 0. There's no other way to get to 0 by multiplication unless you multiply by 0. So we're going to split this. We're going to test both of them. Okay? we're going to say x minus 2 equals 0 and x minus 2 equals 0. So it just so happens in this case that both are going to give you the same answer. When we solve for x, we bring the 2 over, and you're going to get x is equal to positive 2. And then you're going to get that again. Thank you. So it looks like it's the exact same value. So in this case, there's actually only one x-intercept. It's at the number 2. To have one x-intercept, that means the vertex is touching that x-intercept. Normally, or a lot of the time, there are 2. Right? This one is very special. There's only 1. And you can see that because I could have simplified this bracket by saying x minus 2 squared equals 0, right? Because the brackets are the same. Okay, so now that we know that, you can plot that one value here. And that makes this, normally, okay, when you have two x-intercepts, you have the r and the s. There's a little formula called the Axis of Symmetry. Okay, have you ever seen this Axis of Symmetry? And it's where you add the two x values, so like x-intercepts, x1 and x2, and you divide them by 2. Or they're sometimes called the r and the s if it's in factored form. And remember, we just had our factored form. We had x minus 2 times x minus 2, and either could be the r or the s. Now, they're obviously the exact same. But we're going to put it through this to see if it still finds the axis of symmetry, because this would normally be what you do, especially if you had different numbers. Now, we found out that they're actually both positive 2, right, after we did a little bit of solving. So let's plug positive 2 in. We're going to get 2 plus 2, and then we're going to divide it by 2 to find the axis of symmetry, which is going to be 4 over 2, which gives us 2. And the axis of symmetry is actually the x value of the vertex, okay? So we know that it's actually 2, and that makes sense because we just talked about how our only x-intercept is where the vertex is. So that's where the line cuts it through the middle. Okay. If the numbers were different, you would have had a different value. And then from there, to find the y value of the vertex, and we already kind of know what it is, you would take your x value and plug it into either the factored form here or the standard form at the very beginning, this one here, and they would give you the y value of the vertex. So let's plug it into both and test, okay? Let's kind of scroll down. Our one factored form was y is equal to x minus 2, x minus 2. Our other form, well, some very straight. Our other form said x squared minus 4x plus 4, and that was equal to y. Okay, so we just said that if we plug this x value in, it'll find us a y value. So we're going to plug 2 in for the x values. Okay, and we're going to see what we get. On the left side, it's going to be pretty obvious. You're going to get y is equal to, when we plug it in, we'll use blue, 2 minus, whoops, minus 2, and then minus 2. So what is 2 minus 2?
0.
0. So you end up with 0 times 0, which is quite clearly 0. So the y value of the vertex is 0. And again, we already knew that. But if the numbers had been different and it didn't have that vertex, that's how you'd go about it. And let's just test it to see that it would be the same here. Because mathematically, it should still work. Let's fix that. There we go. So we're going to plug 2 in for those values. Y is equal to 2 squared minus 4 times 2 plus 4. And we should get 0 if this works out. So 2 squared is 4. Negative 4 times 2 is negative 8 plus 4. And if you go 4 minus 8, that's negative 4. Negative 4 plus 4 is 0 again. Okay. So even though this was a special case and the x value, the x-intercept happened to be the vertex, it still works out. You can still use those other things to solve it. They're just kind of redundant in the end. And we showed it here that here's your x-intercept. And your y-intercept is actually really easy to see. When you're in standard form, it's whatever the c value is. So the y-intercept is 0, 4. Okay. So we can use those to go about our factoring of this one.